Welcome to the Model Vision Podcast, Avian's official systems engineering podcast. Today we are jumping in with episode 1 of this new podcast and talking about Systems Engineering 101. In this episode, we talk about what systems engineering is, how it's defined, how we're using it in the workplace, and how we're using it to support our customers throughout the Department of Defense. I don't want to go into too much more detail because we do that at the beginning of the episode. So without further ado, I hope you enjoyed this new podcast and I'll see you on the other side. Welcome to Avian's official systems engineering podcast. Today I have Rich, Keith, and Casey with me. Let's kick off with some just backgrounds and general introductions of who you guys are. Rich, do you want to give a quick overview of who you are, what you do for the company?
Sure. So my name's Rich Gilpin. I retired from working for the Navy after 39 years. The bulk of my time with the Navy was working in systems engineering for major programs, such as the F-18 E&F development. I was the lead engineer and level 1 team lead for that. I worked systems engineering for the A-12 and for the E-2D as well. From there, I went to direct air vehicle engineering at NavAir. And then finally, my last job was as the DASN, Deputy Assistant Secretary Navy for Aviation up in the Pentagon. After retirement, I went to work at Sikorsky, where I was the deputy program manager for the CH-53K, and came to Avian, looking for the opportunity to support NavAir in its further development of systems engineering, especially with its future focus towards model-based systems engineering.
Awesome. Keith?
I too retired from NavAir after 39 years. 20 of those years was in the systems engineering discipline. I'm mostly doing new start programs and concept development programs for the Navy, including working at a 3-year stint up at DARPA, working at mission level systems engineering or capacity level engineering, and then retired, came to Avian primarily to do training, to teach a lot of the new engineers on what systems engineering is and how they are going to navigate the process of systems engineering for NavAir, the Navy, and DoD.
Awesome. And then finally, Casey.
Yeah. So my, I guess you could say my journey started pretty much in the Marine Corps. So I spent some time there as a UAV operator. As I transitioned out, I got into simulation and training and actually contributed towards building simulation devices. Along with that, also fulfilled the role of project manager. And I would say that what actually led me to systems engineering is actually being more involved with the engineering aspect of it than project management, or at least being more interested in it. And with that, I decided to get my degree, finish up my master's degree from Cornell University. And that's actually what led me to Avian, to get serious about systems engineering.
Awesome. Cool. So welcome. This is the first episode. So any rough spots that we may have, we'll just blame it on that. The conversation today is going to focus around systems engineering generally, and kind of give an overview of what that even means. So let's just start with that question. In a very basic form, can you guys explain what systems engineering is?
Well, the function of system engineering is a guide, the engineering of complex systems. That's where it was born from, right? So it became something more documented back in World War II when we started building complex systems to support the war effort.
Right.
But there's been some documentation that talks about system engineering going all the way back to building the pyramids in Egypt.
Wow, that's interesting. One thing that I read is that Bell Telephone was actually one of the first companies to use systems engineering. Any other descriptions or anything you want to add to Keith's description, Casey or Rich?
Yeah, just in general, I think in plain terms, systems engineering is the realization of a concept to an actual system. And no different than what Keith is saying, the origin of system engineering was really just to manage complexity. And as time evolves, system engineering has also evolved with it.
I think that the only thing I would add to that, when someone asks me what systems engineering really is, I think of it as the translation of ideas or requirements to a specific design concept, and finally a product at the end of the day that will meet the original idea and design requirements. So it's transition of requirements into product development and into a product that meets those requirements.
Gotcha. All right, so let's talk about now, since we have this basic definition of what systems engineering is, how are we using systems engineering now? And we generally, not just AVIAN, but generally, how are we using it for work with the DoD? And then if you guys have any examples outside of the DoD, that would be awesome too.
Well, I guess that, one quote that I heard, a Harvard professor described the DoD acquisition and systems engineering as the most complex process in the world. Mainly because there's a dichotomy between full lifecycle systems engineering and acquisition engineering as DoD looks at it. So we use this supplier-acquirer relationship as it relates to INCOSE or international standards as it relates to systems engineering. So, we look at defining the requirements, tracking the requirements, and making sure that those requirements are met in the design and implementation on the back end.
Right. Any other examples of how we're using systems engineering, or how anybody is using systems engineering? Is there any industry leaders maybe that are using it that you know of?
I think from past experience, just in general, talking about systems engineering, just to kind of rewind it back and to build off of what Rich and Keith were saying, the process itself is multi-tiered. In a sense, it is complex. But one example that I always kind of fall back to provide proof that system engineering is valuable is really a customer infinity process. And essentially what this is something like an RFP comes out. We're able to analyze that document, analyze the requirements, and get down to a point where we can understand what the customer is truly requesting for, what they're truly asking for. From that point forward, we essentially almost have a cheat sheet. We know in our own terms what they're asking for. We've defined those. We can then take that, validate it with our customer, and then in return, once we're building our system, we know that it has to do these specific things and has to perform at this specific level. So this is another example of what systems engineering is and what it can actually offer.
But at the same time, talking with a customer and making sure that we understand his needs, we also have to provide some quantitative input back to the customer as far as technical maturity, capability, and that type of thing. So we actually totally understand what his needs are and then what the end up process is. Henry Ford once stated that if I just listened to the customer, I would have given them a faster horse. Right? So it's a back and a forth type of relationship between the systems engineer and the customer stakeholder to make sure that we totally understand the context associated with the requirement and then build a requirement that only meets the minimum criteria to get that requirement to the warfighter.
Gotcha. So I think it's interesting what you said, Casey. So the process of systems engineering starts even before we maybe are awarded the work that we're going after. We want to prove to the customer that we have a full understanding of what they're asking of us, and then basically move through that process. And I mean, you guys can correct me if I'm wrong, but is that what that means? So we're applying systems engineering techniques or tactics to an RFP, and then we have a clear understanding when we get into the work that this is the process we're going to go through. Is that what you said?
I would say what we're going back and forth with is just the different life cycles of a project. And I think what Keith and what the team is extremely familiar with is defense acquisition systems. But there's also generic life cycle models as well. And so within a generic life cycle model, you have what's called the conceptual phase. Typically an RFP comes out. With that type of construct, there's usually limited communication flowing between yourself and the customer. But utilizing systems engineering tools, we're able to get down to the root of the problem, And like I was saying earlier, provide somewhat of a cheat sheet for the engineering team to build a product.
Yeah, cool.
Going back to our original discussion, this is all about defining needs, defining the performance requirements to meet those needs, and then translating those into a physical weapon system or end product that you're trying to develop. This is a process that's done, frankly, across commercial and DoD industry alike. The application's a little bit different within the government just because, but in general, systems engineering is applied in just about everything we do. It could be as simple as just like when most people go to buy a house, the first thing they figure out is, well, how many people are going to be living in the house? How many bedrooms do we need? We want shelter. We want to stay warm. We want to stay cool. We want to entertain ourselves. We want to have enough places to go to the bathroom. So everything is covered as a set of needs and requirements, and then you translate that into an end product. And oh, by the way, can I afford it? Which may get you to go into an iteration of understanding of your needs and requirements until you get to something that meets everything that you want to accomplish.
Yeah, that actually helped me understand a lot, and leads into my next question. So I'm going to ask two very different questions. Let's think before World War II, before maybe we even categorized it as systems engineering. Rich, you just gave a great example of the house buying process, but are there any other examples that could help people understand what systems engineering is at the very basic level? So maybe it has to do with Ford, like you were talking about, Keith, where it's something with their assembly lines or something like that.
Well, I mean, it's the understanding the concept of the requirement, but as it relates to DoD systems engineering, at the government level, well, not only are we helping define the requirements, for, like Rich mentioned, the house, the size of the house, how many bedrooms, the functional flow of the house, how it would be used, but we're also the building inspectors all along the way to make sure that we have a foundation that works.
Right.
We understand, how the framing was done and the electrical and the high vac and so on, so that not only we get the end product that meets the customer's needs, but we also understand where we can, those interfaces that we can actually grow the house from in future needs. So, with that said, system engineering is not just building the house, but it's also engineering change proposals.
Yep.
It could be upgrades to existing system, pre-programmed improvements. And so we understand that, and we use new tools like, Rich was talking about earlier about model-based system engineering as a tool that gives us more insight on what the context and those interfaces are.
And just to build on what Keith said in terms of ensuring that being the building inspector, if you will, for the house, what we're really talking about here is verification, validation, testing, to ensure that the system meets requirements. So when we talk about verification, we want to know, does it work as it's intended to work? When we talk about validation, we're asking the question, is it doing the thing we intended it to do? Did we build the right thing in the first place? So the whole evolution of defining needs and requirements through the design process, through validation, verification, and to release of an article that works, and then ultimately to the sustainment of that article in the fleet, with maintenance and supply.
Gotcha. So this is actually super helpful for me because now I'm understanding it more. And now I'm going to lay it out in my terms and see if it aligns with what you guys are saying. So basically, we're creating this plan from start to finish, laying this plan out to our customers, and making sure that we're sticking to this plan, improving this plan along the way, and that it's consistent improvement, consistent reaching of those milestones that we set, and making sure we get to that endpoint in a fast and maybe efficient manner.
Yeah, and along the way, we lay out what are the risks associated with the current design or the current implementation, funding, stream, technology. So we'll lay out those risks and we'll build mitigation plans associated with those risks. So risk management is a management tool. Risk analysis is a technical term or hard skill associated with systems engineering. So along the way, we'll provide those insights on how well we're doing to look at risk and also opportunity as it relates to the ongoing program. Because as you know, there's always unknown unknowns, right? So we talk about, they say, think out of the box. Well, we haven't even defined the box yet. So that's kind of the hard process for us to go through.
Yeah, definitely. All right, so let's shift gears a little bit and talk about the future of systems engineering. What does that look like to you guys?
So right now, systems engineering is a process that a methodology has been working for a long time, and it's worked fairly well. We've gotten in trouble because the systems, as Keith has alluded to, have gotten extremely complex. Not only in terms of the technology that goes into building modern naval aircraft today, which is extensive, and but also the desire to build an aircraft that will work within an overarching system of systems that the Navy operates. So the Navy doesn't operate just aircraft; they have ships, they have weapons, they have missiles, they have sensor programs across the board, and then we have to work within the confines of the other services. So the future for systems engineering is not just will my system work, but will it work within a construct of systems. And looking forward to means of achieving that is this thing called model-based systems engineering, which is an approach to modeling all of the requirements rather than doing it in a paper-based system. And that is going to really make the tool much more powerful, but it doesn't change the discipline of systems engineering as it sits. So that's where I see the future going. And it's pretty exciting to me to be working within a company that has such a deep bench related to systems engineering, not just because we've all done it before, but we have a deep understanding of what systems engineering is supposed to be doing. And the application of these new tools, we can make sure that we don't lose the pedigree of what good systems engineering is all about.
Yeah. Any other inputs about the future of systems engineering? I do want to say we are going to talk about model-based systems engineering in the future, and we'll dive deeper into what that is on another episode.
Yeah, I think the future of systems engineering, I think just like physics doesn't change. We just use new tools to better understand physics.
Right.
Systems are becoming more and more complex. In the past, we used to build individual systems that only worked independently to themselves. And then as we started looking at how these independent systems started working with other systems, now we started looking at systems approach and how those would work together. So every time we get a requirement from, let's say, through the JSIDS process, the JROC, those requirements not only are there for our implementation of that system they desire, but it's also linked to multiple other systems out there that meet campaign or mission level requirements that the rest of the Navy requires or DoD requires. So our level of complexity is going up exponentially. So our tools and some of our processes need to keep pace with that exponential growth.
Yeah. So basically what I just heard was improving the tools. I don't know. Is there a company that produces a specific tool, and then I guess what would that improvement look like?
Well,
So I think there.
Go ahead.
No, sorry. So I think there are a number of tools out there. The one I'm most comfortable with is Nomad's Cameo system architecture, in which it does exactly what Keith and what Rich are talking about. So I can decompose a system, which is significantly faster than reading a text-based document, and I can now share that system amongst Rich and Keith, and now we all have a shared mental representation of a system. So.
Yeah.
But it allows us to look at that same system with different viewpoints, right? So that we, if you're looking at it for performance, I may look at it for structure. Or Rich may be looking at it for supportability, but it's the same model. And I think that is where the value is.
Correct.
And because we have such complexity and be able to trade off the very narrow design margin of a lot of our complex systems, we need that interaction of model-based systems engineering so it allows us to understand what those margins are and be able to trade off capability, between different subsystems in order to get an end state without wasting a lot of what we call swap, size, weight, power, and so on.
Yeah. Cool. So let's wrap this up with one final question. Say I'm in college or I'm already in my career as an engineer. How do I get into systems engineering? What courses in college, and maybe Casey, you have some pretty good insight because you just graduated, like you said, your master's program. What courses in college do you need to take? If you're already an engineer, what trainings could you take to transfer into systems engineering? Any inputs on these?
Yeah, so when I first started, the technical background or engineering background significantly helps. And so getting into Cornell, going through the system engineering program there, I think what will really help guys out is just a solid background in technical related industries or engineering specifically. When it comes down to systems engineering, you're essentially putting yourself in somewhat of a managerial role who can help out specific engineering fields, but who can also manage a project from a higher level, if you will.
Yeah. And Rich or Keith, are you familiar with anyone that said, I'm an ex-engineer, I want to transfer into systems engineering, and was successful to do that?
Yeah, absolutely. And I think many of the systems engineers that are on board at NAVAIR today and that we're looking at from our perspective are people who did basic engineering in a specific field, whether it's I spent much of my engineering time in air vehicle, airframe, and structure development, but later on transitioned to the broader development of aircraft across the board. And the systems engineering field is extremely exciting if you're into looking at how do you build an airplane? How do you build the whole thing and bring it all together and have it work? How do you define the needs and translate those into an actual product that people will use and get real capability into the hands of the warfighter out there? So it is, in many ways, a mix of program management and engineering, but the real focus is on the technical development and technical planning associated with a major project. And I've seen people do this work, whether it's in major ground projects like building a bridge, or my son-in-law is working on developing a data system for Google. Those kinds of things all require program management and engineering management at the top end. Keith alluded to one of the key disciplines here is risk management. To understand we need to always know in any program, what are my technologies that I'm chasing? How am I doing in terms of achieving that? And what are my risks associated with doing it? And where can I get in trouble? If you have all those things in mind and you understand where you are on cost, you've got the whole thing covered. So systems engineering is that opportunity to do that, but stay technically grounded and not be an MBA kind of guy.
Yeah.
Gotcha.
Yeah, trying to expand on what Casey and also Rich mentioned, the having a technical degree gives you that depth that you need to show that, hey, I understand how to learn and so on. System engineering processes gives you that breadth of information needed across all the disciplines. But if I was talking to someone in college says, how do I get into systems engineering? One, you have hard skills you need to look at is math, mechanical skills, physics, computer skills, troubleshooting, prototyping, those types of things. Right? Those are hard skills. But a systems engineer also needs those soft skills, which are the communications, teamwork, time management, problem solving, critical thinking, leadership type of functions as well to be a very efficient systems engineer.
Gotcha. That's some good points because I think all three of you mentioned really great stuff. And as far as, like you just said, you need the hard skills and the soft skills. You need to know the technical pieces. You need to know how to also work with people. So I think some really good points there. I think we can wrap it up here. So Keith, Rich, Casey, thank you for joining me on the first episode of AVIAN's Systems Engineering Podcast. On the next episode, we're talking about model-based systems engineering specifically, and we'll give a little bit of a overview and kind of do a deep dive into what MBSE is. So again, thank you guys for joining me, and I will see everybody next time. The Model Vision Podcast is brought to you by AVIAN. At AVIAN, we provide extraordinary support in the areas of model-based systems engineering. We help our customers detect problems early using modeling with a purpose. With AVIAN's MBSE network, we provide a collaborative ecosystem to access, define, and implement a tailored MBSE approach for program success. AVIAN's model-based systems engineers work with SysMill using Cameo software to replace the document-centric nature of typical systems engineering. Our engineers expose vulnerabilities within your system before implementation, ensure speed to the fleet with a solution that brings clarity early, enhances the chief engineer's capabilities, creates a holistic view allowing for better decision making, and simplifies complexity. Everything works together to bring certainty to your design. If you're interested in learning more about AVIAN's capabilities within MBSE, you can visit avian.com/capabilities.